So, chi-squared test for independence. I want to talk through these notes. First, a slight disclaimer, I guess. If you are a biology major, psychology major, and I'm sure there's a few others, you need chi-squared in your major. You may have already done it. Okay, we've talked to those departments. Now, technically in real life, there are 3 different chi-squared tests out there. One of them is just based on 1 sample. 2 of them are based on 2 samples. There is not time to do 3 different chi-squared tests in here. So what we do in my class is called the chi-squared test for independence. It is a 2-sample one. I feel like that's all you need just because, well, it's very similar to the other 2-sample one for when you do it in your major. And it's actually much more involved than the 1-sample one, so it's not like, we're not giving you the hard stuff. I'm giving nuts and bolts here, not a lot of background. So if you are one of those majors and you are doing chi-squared, you may want to take 10 minutes one day to go read the 3 pages in a stats textbook for the background for chi-squared. Okay, so I am just giving you nuts and bolts of it. So little disclaimer just for those couple of majors that would actually use this. Also, to remind you of something that's not on the exam because it relates to this. The other part of handout 8 probability were those data tables, and then there was, and I know it was the first page, I guess, on test 2. It asked you to check for independence, and you had to do the 2 probabilities, and when you multiplied them, did it equal the intersection? Remember that? It wasn't hard. Actually, that is not the appropriate technique. Not in real life. In real life, it's a hypothesis test related to that. So that technique of just doing those probabilities, we will never do again. Every textbook does it more as an intro to get you to start to think about the stuff, but the appropriate, correct thing is this chi-squared test for independence, okay? So we are going to, if you just want to look on the back, I just want to show you, we're going to have data tables, but we're not doing those probability stuff. We're going to teach you what we're doing, okay? This is absolutely back to categorical variables. That was kind of the same thing in those probability data charts on handout 8. So we're dealing with 2 categorical variables, and we're trying to figure out, if they're independent or not. Not means dependent, associated, related. All those words mean the same thing, so don't get confused on that. Dependent, associated, related. Those are all synonyms. Who knows what comes out of my mouth? I can tell you right now exactly what your HO and HA are going to look like. You're going to write you have to say what the 2 variables are. Like, we might end up doing something with a lion and position, or seatbelt and gender, politics and gender, or whatever. So you'd say politics and gender are independent. Politics and gender are dependent. So you just have to fill in what the 2 variables are. But it tells you exactly right there. So we're not doing mu's and p's, nothing like that. There really is not a step 2. There's not much criteria that you need to be able to do a chi-squared. Actually, please don't write this down. That's why I didn't write it down on the notes. For those few majors who are going to have to do chi-squared. Again, if you look on the back, see how there's different little cells for the data? The only requirement for chi-squared is that you have at least 5 in each one. And if you look at all these, we do. So I'm not testing you on that part because it's such a tiny detail. Okay, the test statistic. We used to have T's and Z's, right? We don't have those anymore. We have this thing called chi, so it's that fancy X. It's called chi, the chi-squared. This formula is on your cheat sheet. Let's see if I have the cheat sheet. Not handy, but that's okay. It was the only row that you haven't done on your cheat sheet yet, okay? And chi-squared equals, so this looks kind of messy. I just like to point to things, so I'm going to write it up here. All right, first of all, please note that that is the summation sign. We've never had more than 1 formula in our test statistic, right? So no, actually, we're going to have numerous of these things to add up and put together. So like, again, if you look on the back for politics and gender, See how there are 6 different entries? Technically, we're going to have 6 of these things to add up, okay? Our calculator is going to do most of it for us. That's the good news. So really very different looking test statistic than what we've come off of. Observation, I spelled it out on the sheet, right? That is the actual, what did we see from our survey? Those are the numbers that you see on the back. Those are the observations, the actual data we collected. Expected, so this is where I'm not going to give you the long version. Expected really says, okay, if there was nothing going on between gender and politics, how many would we have expected to see in each? Okay, so, and our calculator is going to calculate that for us. I did put the formula for expected on there. We're not having to do that by hand, though. So you see where it says expected is column total times row total divided by grand total? You may want to circle that and just put a little note, not needed. If you're one of the majors, biopsychology, you might need that. Okay, so that's why I put it on there. I'm trying to handle sort of everything all at once. There is going to be something that you need called degrees of freedom. It's the number of rows minus 1 times the number of columns minus 1. We'll get back to that. TI-83 shortcut, because I only do this not very often. I have told you exactly what to do there. We're going to practice that. We are using matrices. I'm just curious, how many people have ever used matrices on the calculator? Yeah, so up until 4 years ago, I never had. I used to teach this entire topic doing everything by hand, and it was just really boring and terrible, okay? My 15-year-old taught me how to do it. I was scared to death of matrices. So my point is, if I can do it, you can do it. So I'm going to teach you how to do that. So don't let that word matrix scare you. I learned how to do it. Then I am going to need you to be able to look at the expecteds, and it tells you there. So I just want to make sure you see that there are exact directions on how to work the calculator. So once you leave me today, if you forget what I said, it is on here, okay? The best way to do this is really just to do a problem. So let's do, might as well do the first one. Sorry, let me get my answer key. There we go. Now this very first problem, we might get through 2 problems today. The very first problem we do, I want to show you all the little nuts and bolts. We're actually going to show all 6 formulas because I do want to be able to talk about it just a little bit to try to give you some understanding, not total understanding, just some. But then the second problem we're going to do, we'll do it a little bit shorter, and that's what I would hold you to on the exam. So the first one's going to be a little bit longer. All right, first one though, so yeah, you got to flip to the back. We're going to do politics and gender. And the very first thing you have to do if it hasn't been done, well, actually our calculator, see, I still have the old way. No, we're not going to need the row and column totals. Calculator's doing everything for us. All right, I'm just going to start into setting it up. Chi-squared number 1. So we're talking about trying to figure out, you know, if something's going on between gender and politics. So we assume basically independence until you prove otherwise, and that's why it says HO is independent. So gender and politics are independent versus HA, gender and politics are dependent, or you can use the word associated or related, whatever you prefer. So just to remind you, there's not a step 2, but I just want to kind of show you how we are still following steps of hypothesis tests. There's not a step 2 though. So now we got this chi-squared thing. Maybe I'm going to go ahead and set up the template first, and then we'll pick up our calculators and all work together. Because we have observed, that is the actual data. 35 minus, well, I don't even know my expecteds yet, all over expected. So no, I can't fill in everything, but I'm trying to show you that yes, there are 6 of these. So of course, I'll have to come back and fill in my stuff. But that's what that summation sign be. Let me just get my numbers first before I talk. 50, 44, and 21. So we would have 6 different things we're putting in a pile together. That's how chi-squared works. And I wanted to show you this because this is really what chi-squared does. It goes to each of the 6, and basically, I'm taking some freedoms here, figures out how much off you are, 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 and puts it in one bucket and says, all together, this is how off you are. And we try to see if that's a small number or a big number. So chi-squared can end up saying, yeah, collectively you're way too off, you're way too far off. We think something's going on, we think it's dependent. What chi-squared does not do is pinpoint where it comes from. It's not going to pinpoint, oh, it's the female conservatives that really did the most or whatever. It's not going to pinpoint it. There is something called analysis of variance, ANOVA, that goes in and pinpoints it. And I bring that up because I had a psychology major student last semester who took Math 220 with me. She came by my office on Friday and is like, yeah, we're doing ANOVA. I'm like, yeah, I haven't done ANOVA in 20 years. So if you take that psych research method, maybe 216, don't quote me on that, you will be doing chi-squared and the follow-up ANOVA. So in case you're a psych major, this is really important stuff. If you're an art history major, no, right? That is just the way it is, right? It's a gen ed. Okay. Once we get some numbers here, I'll be able to say more, but let's all go focus slowly on our calculator. And I think, yes, I am going to have to make a comment about new calculators versus old calculators as we go. I don't do this very often, so I'm going to follow my own directions. Okay, we need to get our data table into the calculator. So go find, go find your x to the -1 button. The second function of that should be matrix. I'm sure there's a calculator that has matrix somewhere else, but you're trying to find the matrix button. So second of x minus 1 pulls up matrix. Okay. Then you're going to right arrow over to edit, and you might as well go for matrix A. Why pick anything else, right? You do have to hit enter to select matrix A. And this, so your calculator, mine says 2 times 2 right now. It's row times column. And I did not put that on your notes anywhere. So make sure you know. Oh, yeah, there we go. It's row times column. So on our gender, politics, how many rows do we have of data? 2. And how many columns do we have? 3. So you got to make it say 2 times 3. So 2, and then move over to the other one, make it a 3. Hit enter. When you do that, you should have the 6 spots to type in your data just like on the handout. And so you type in your first one, 35. You can then arrow and enter, arrow over, type in the other one. Just watch your calculator to see where it sends you. It's going to send you horizontal first. When you get done, your data table right here should look just like what you see on your handout. Have I lost anyone? Okay, you just entered a matrix. All right, now we have to run the chi-squared test. So it tells you, go to the stat button, because that's where we were going for a hypothesis test, right? And test. You got to find chi-squared. This is where new calculators, old calculators are a little bit different. Old calculators, we only have one choice. Our life is easier. It says chi-squared test. For me, it's C, old calculators. New calculators, I believe you also have a chi-squared GOF. Does anybody see that? You do not want that. You want that one. Do you have one that looks like that? Yes, you got to make sure you pick this one and not the other one, okay, for the new calculators. Okay. Chi-squared. We hit enter. Now, this is what confused me the first time. There's nothing to do here. I thought it was asking me something. No, it's saying, hey, your observers are in matrix A? Well, yes, they are. What it's telling you is, okay, then we're going to run the chi-squared test, and we're going to put the expecteds into matrix B for you. So just kind of say thank you to your calculator. Okay, I got it. So all you got to do is hit calculate. You're not doing anything there. You're not changing anything. Okay. Now, we get some info here, and then we're going to have to go to another screen. This chi-squared, once it did all of that stuff, here we go again, is 4.4, which looks reasonable. I've seen chi-squares of 253. So, everything we know about that normal curve, this is not normally distributed. We're not thinking of numbers like 2 and 3 and 5. They can really blow up on you because of the square. But did everybody get 4.4? Okay. While we're here, though, I'll make that comment in a minute. Just so we don't have to rerun this, I just want to, you know how P has always been P-value? Same thing. This hasn't changed. I'm just going to write that over here for a minute so I don't have to rerun my test. I'm not ready for it, but okay. Now, I want to be able to see the expecteds. On this one, I'm going to show all 6. On the exam, you're going to have to show me one of them. So you're going to have to do this next step. And it says, to see the expecteds on the TI-83, you're going back to that second of the x minus 1 to pull up matrix. You're going over to edit. Remember how the calculator told you it put the expecteds into matrix B as in boy? We want to go look at B to see what it did. So arrow down to number 2, matrix B, hit enter. Those are the expected. So right now we're going to fill this in. Again, you won't have to show these all to me on the exam, but you will have to show one of them to me. So you're going to have to go to this little spot to get one of them. Mm-hmm.
And that number also goes in the denominator? Or?
Yep.
Okay.
Yeah, I'm so consumed with trying to record that I keep looking, and I do have a split focus right now. I apologize.
It's cool.
I used to make y'all work all that stuff out by hand, so aren't I nice now? I want you to write it down first, and then I want to talk about it before we finish this. Just again to try to give some understanding as to what's going on. You probably don't, but I mean, you might. I don't know if you, how many science course you've ever taken. I don't care if it's high school or college. Something called percent error. I'll go back to, I'm going to ramble for 1 minute. Go back to that science fair project that came through my house. We were estimating grains of rice in a little mason jar, and then it was like honeycomb, big cereals, and another one, okay? So let's say on the cereal there were 100 pieces of cereal in there. And let's say someone guessed 90. Okay, they were 10 off, right? Let's say there were 10,000 grains of rice, and someone guessed 9,990. They were 10 grains of rice off. Okay, so they were off by 10 grains of rice out of 10,000, or they were off by 10 cereal pieces out of 100. So they guessed equally? Is that right? Why not? I got people nodding saying no. Why not? They were 10 off from each. In your own words.
Like the grains of rice is like much bigger value.
Yeah, 10 out of 10,000, that's like incredible. If I wasn't so out of it, I could tell you the percent. 10 out of 100, oh, that's 10%. You were 10% off there. The other one, you're probably like 1% off. That idea of just not how far off you are, but as a proportion of what the true answer was. Very big in science class, okay? You know, that's kind of what we're doing here. We're not only looking to see how far off you are, but as a proportion of what it should have been. Now, we got that whole squared thing. We've seen that throughout all of Math 220. We always have to square things because we don't want our positives and negatives to cancel out. A real percent error in science class, you do not square, okay? But that's just this statistical thing, so when I add things up, they don't cancel out. So I'm just gonna stand here and say, okay, if something turns out to show a difference, where did it come from? God, we're not even 1 off here. I feel like it's definitely not coming from there. I'm 4 off here out of 32. I'm almost 5 off here out of 10. So even though the numerators are fairly similar, yeah, but this was out of 30-something. That was only out of 11. Here, I guess I'm 4 off out of 48. That doesn't seem like. Here, I'm like 5 off out of 16. So if this thing turns out to be significant, I can just visualize the data and tell you it came from the conservative stuff. Again, chi-squared is not going to tell you it's the conservative part. That would take that analysis of variance we don't do in Math 220. But I can kind of look to tell you if something happens, it's coming from there, okay? Now, so that equals 4.4. All right, we have all of that, so I'm going to erase this so I can put the last 2 steps on this middle screen here. Now, chi-squared, squared, has to be positive. So this relates also back to test 4. You know your p-value expression? There was still some confusions of how do I know what symbol to use? And during review, we were talking about how, well, if you got a positive test statistic, you're doing greater than. If you got a negative test statistic, you're doing less than. Same thing here, chi-squared has to be positive. Let me tell you, if you get a negative chi-squared, you've definitely done something wrong. So p-value is the probability that chi-squared is greater. I can tell you it's always going to be greater because it has to be positive. 4.4, that chi-squared that we had gotten from step 3, equals, your calculator told you the p-value earlier, 0.1089, or if you just want to call it 0.109, that's fine. Oh, okay, good. It said to use an alpha of 0.05 for everything. So same thing is oh yes, this is all reminding me of issues from test 4. Some people have their p-value to alpha memorized completely backwards, and so you missed it on every question. So maybe that bears repeating. If the p-value is less than or equal to alpha, you reject HO. This is a set in stone. I don't care what your HA is. I don't care if you're doing mu, p, independent, paired, or chi-squared. This is a set in stone for the rest of your life. It has nothing to do with me in Math 220, okay? So please make sure you memorize that correctly. So is 0.1 less than or equal to 0.05? No. So this is given, we're flowing in step 5. Do not reject HO. There's not evidence of HA. So you can see some of that stuff we've already learned is flowing into this new topic. Just look at your HA. There is not evidence gender and politics are dependent. I think I've been somewhat successful